Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 1598, crawler log folder. The Leetcode file system keeps a log each time some user performs a change folder operations. Okay, the operations are described below. First, see here, if it is dot dot slash, you want to move to the parent folder from the current page. If there is no parent folder, then remain on the same folder. Okay, sorry, if there are already the main folder, remain in the same folder. Okay, don't move to the parent folder, just remain in the same folder. Okay, now if it is dot slash, then remain in the same folder, just do nothing, just remain there. Okay, if it is x slash, where x is just any directory, then move to the child folder named x. Okay, you have to move towards the child folder named x. It is guaranteed that always that x exists. Okay, now you are given a list of strings logs, where logs of I is the operation performed by the user at the ith step. Okay, the file system starts in the main folder, then the operation is in logs are performed. Return the minimum number of operations needed to go back to the main folder after change folder operations. Okay, they are asking us to find how many operations we needed to go to the main folder after some certain operations are done in the current main folder. Okay, that means just take for example, if there is a main folder and i I just gone to a child directory. Now again, to go back to the parent directory, that is the main folder, how much step I needed? I needed one step, right? So that's the output we have to return, the one. Fine, fine. So let us see some examples so that it will be more clear. Just see here. This is the first example. It is what? X slash. There are three possibilities. One is what? X slash. It means child directory. Move to the child directory. That child directory will be exist. Surely it will be exist. Okay. Okay. Now the next thing is what? It is dot dot slash. It means go to the parent directory. Go to the parent directory. Now again, dot slash, just remain safe, don't do anything, remain safe, don't do anything. Okay, now let us see here. First of all, go into the child directory. Usually we are in main folder and we are gone to the child directory d1. Okay, then again go to the d2 went. Now again, dot dot slash, it means go to the parent, go to the parent, just go to the parent. Now my current folder is where? D1. I gone to the parent, right? So it is D1. Now again, it is what? D21. So again we are going to the child directory D21. Fine. Again, a dot slash. It means just remain. Just remain. Don't do anything. Okay. Now we are at where? D21. Now how many steps is required to go to the main? I can say the step required to go to main is 1, and then again 2. So 2 is my answer. Fine, fine. So this is what I'm trying to say you in that main folder and child folder example. Okay. So the answer is 2. Okay. Now let's take another example. See here, this is another example. Initially we are at main folder. Now d1 slash, it means we are going to the child directory d1. Now again d2 slash, so we are going to the child directory d2. Yes, again what? Dot slash. Don't do anything, remain same. So remain same at step 2. Now again d3 slash. So we are going to the child directory d3. Now again dot dot slash. It means go to the parent directory. So go to the parent directory. So we are at where? D2. Now d31. So we are going to the child directory d31. Again, there is no any other operations. So how many steps required to go to the main folder? I want one step, another step, and another step. So totally I want how many steps? I want 3 steps. So 3 is the output here. Now do you got some clear vision of this example, right? Now see this D1. So we are going to the child directory. So we are at where? Child directory D1. Okay, main to child directory D1. Now again dot slash. So we are going to again to main. Okay, again it is dot dot slash. Already we are in main. Where do I go? Okay, so remain same. So main. Again dot dot slash. Again remain same. Don't go because we are already at where? Main folder. Okay, that's it. So this is the core logic behind this examples. Okay, now let us analyze this and we can come up with how can we do this. Okay, there are only three possibilities. These are the three possibilities I have written here. Okay, if it is dot slash, we don't do anything. Okay, just continue. Okay, one problem is cleared. Now the next problem is dot slash. Okay, if there is a dot slash, I want to go to the previous directory. Okay, okay. We are going to the previous directory. Then it means the directory that I opened lastly is the directory I am taking first. It's the directory I am taking first because see here, this is an example. See here, this 2.1 is a directory I have opened at last. If I do dot slash, then this is the directory I will be what? I will be going to the previous directory to D1 and I will be going from this to this. It means just like removing. Okay, not like removing, like we are traveling from here to D1. So from here I can say it is last to first. So I can say it is LIFO, which means last in first out. If it is last in first out, what should be the data structure? It is what? Stack. Stack. Okay, it's stack. But how can I implement stack in this? Okay, let me take a stack. Okay. First of all, what's the value? D1. So just push it. Just push it. We are going to the child. Okay, just push it. No, again D2. Just push it. It is also child. Okay, now dot what? Slash. It means that we want to go to the previous parent. So what? Just pop it out. That's it. Just pop it out. We have an element inside the stack. So just pop it out. If we don't have any element inside the stack, don't do anything. Okay. Now again D21. Again push it. Again push it. Again what? Dot slash. Dot slash means what? Just do continue. Don't do any stuff. Just continue. Now at last, how many directories we have opened currently? We have opened 1 and 2. So my answer is 2. Because to move to the main folder, we want to what? Jump from D21 to D1, then D1 to main folder. So I can say what output is 2. The length of the stack. Length of the stack. That's it. Simple, right? It's simple. Okay. So this is the what? Stack approach. Now tell me about the time complexity and space complexity for this approach. Let me say time complexity. What is the time complexity? I can say it is O of n because we are traversing only one time to this all elements in the array. Okay, what is the space complexity? I can say space complexity is O of n because we are using what? Auxiliary space. Fine, fine. Now, after this, we are going to optimize it. But how can I optimize it? Okay, let me take this example. Okay, let me take this example. Fine. If I know the depth or how many child nodes are opened, then I can easily calculate how many child nodes should be closed. If I know how many child nodes are opened, I know how many child nodes are opened, then I can know how many child nodes should be closed. Yes. So initially I am taking a child directory as 0. Okay, initially I am taking child directory as 0. Now I have opened what? D1. So I can say recently I opened how many child? 1. 1. Yes. Again it is D2. D2 means again I have opened how many child? Second child directory. Now take it as 2. Again dot slash. Dot slash means do nothing. Just do nothing. Okay. If we start do nothing. Do nothing, just continue. Now D3 slash. Now again I am opening another directory. Again I am opening another directory. So it is 3. Now dot slash. It means go to the previous. That means -1 which is equal to. Why? Because we are closing that directory and moving to the parent, right? Again D31 plus 1 which is equal to 3. Why? Because we are opening a new child directory. Okay. Finally the answer is of 3. So my output is of 3. So this is how we can do without using the stack. So what is time complexity? It is O of n. And what is space complexity? It is O of 1. Because we haven't used any auxiliary space, but that we have used stack. So because we are traversing this whole array one time. So that's why we are using O of n. Okay. Now it's time to see the code. Yes, see here. Result is equal to empty stack. Now this is stack. Now for I in logs, if I is what? Dot slash. Dot slash means go to the parent directory. And if result if there exists any element in stack, then only we want to what? Then only we want to do pop of result. Okay. If it is dot slash, just do nothing. Okay. Now else we want to add it into our result. Okay. Then after that, after doing everything, we want to return the length of that result. Okay. So this is a stack approach. Let me submit it. Yes, it is submitted successfully, right? Now, going to the next optimal approach. Optimal approach is just using a variable, a constant space, right? See here, this I'm using instead of that stack, just using equal to 0. Then, when this result is, when I is equal to what? Dot slash, we want to go to the parent, right? We want to go to the parent. But we want to check whether there is any child directory open so that we can -1, right? If it is greater than 0, I can know it is a child directory. So result minus is equal to 1, right? If I is equal to dot slash means just continue, do nothing. Okay. Else I want to do what? Result plus 1. Because we are currently opening what? A child directory. Now return the result. That's it. That's it. Let me submit it. Yes, it is submitted successfully. Thank you.